In climate science and biogeochemistry, we often quantify carbon stocks using the unit gigatons of carbon, abbreviated as GTC. 1 gigaton equals 1 billion metric tons, or 10 to the 15th power grams of carbon, resulting in a cube about 764 meters on each side. For scale, here is a human figure standing 1.8 meters tall. In this context, biomass refers to the total mass of carbon stored in living organisms, plants, animals, microbes, and fungi. It's a key component of the global carbon cycle. Let's now examine how this carbon is distributed across different biomass categories. Let's zoom in on the biosphere, starting with two of its most iconic inhabitants, wild birds and wild mammals. This cube represents the carbon mass of all wild birds on Earth, about 0.002 gigatons of carbon, or 2 million tons. That includes everything from hummingbirds to condors. Compressed into pure carbon, this cube would measure roughly 96 meters per side, about the height of a 30-story building. Elegant, lightweight, and surprisingly compact. Now compare that to wild mammals, from elephants to wolves to whales. Their total biomass is around 0.007 gigatons of carbon. This cube spans 146 meters per side, taller than the Great Pyramid of Giza. Still modest, considering the scale of the planet. Together, wild birds and wild mammals make up less than 1% of global biomass. Yet their ecological impact is massive. Let's move from the wild to the domesticated. These two cubes represent the carbon biomass of humans and livestock, the dominant mammals on Earth today. This cube contains the carbon mass of all humans alive today, about 0.06 gigatons. If compressed into pure carbon, it would form a cube nearly 300 meters per side, taller than the Eiffel Tower. Despite our numbers and global reach, our biomass is still smaller than that of the animals we raise. Livestock, cattle, pigs, poultry account for 0.1 gigatons of carbon. That's more than humans, and nearly 2/3 of all mammal biomass. Together, these two cubes represent the anthropogenic reshaping of the mammal kingdom. Wild mammals now make up just 4% of the total. Now we enter the realm of the gelatinous, cnidarians. This group includes jellyfish, corals, sea anemones, and siphonophores, organisms that drift, sting, and build entire reef ecosystems. This cube represents the carbon biomass of all cnidarians, roughly 0.1 gigatons. That's the same as all livestock, and nearly twice the biomass of humans. Despite their soft bodies, cnidarians play a hard role in the carbon cycle. Corals build limestone cities, while jellyfish contribute to deep-sea carbon export through mass sinking events known as jelly falls. Next up, mollusks. This diverse group includes snails, clams, squids, octopuses, and mussels, soft-bodied invertebrates, many of which build calcium carbonate shells. This cube represents the carbon biomass of all mollusks, about 0.2 gigatons. That's more than twice the biomass of humans, and double that of cnidarians. Mollusks are not just abundant, they're ecologically vital. They filter water, cycle nutrients, and even sequester carbon in their shells. Some species, like bivalves, are being studied as potential contributors to blue carbon strategies. Now we turn to the annelids, segmented worms like earthworms, leeches, and marine polychaetes. Often overlooked, these creatures are fundamental to soil health and nutrient cycling. This cube represents the carbon biomass of all annelids, about 0.2 gigatons. That's the same as mollusks, and more than 3 times the biomass of humans. Annelids are ecosystem engineers. Earthworms enhance soil structure and fertility. Marine polychaetes recycle nutrients in ocean sediments. Their biomass is a testament to their quiet dominance beneath our feet and below the waves. Now we turn to the vertebrates of the sea. Fish. From anchovies to tuna, mesopelagic lanternfish to deep-sea giants, their collective biomass is immense. This cube is 674 meters tall and represents the carbon biomass of all fish, about 0.7 gigatons. That's more than 10 times the biomass of wild mammals, and over 11 times that of humans. Now we meet the most numerous animals on Earth: arthropods. Insects, spiders, crustaceans, centipedes, and their microscopic cousins. They crawl, fly, burrow, and swim everywhere. This cube represents the carbon biomass of all arthropods, about 1 gigaton. That's more than the biomass of all fish, and nearly 17 times that of humans. From insects to elephants, krill to humans, the animal kingdom spans every habitat on Earth. But how much carbon do all animals contain? Roughly 2 gigatons, just a fraction of global biomass, yet ecologically immense. This cube represents the carbon biomass of all animals, terrestrial and marine, vertebrates and invertebrates. It's nearly 1 kilometer tall, dwarfing even the tallest skyscrapers. Protists are the single-celled eukaryotes that dominate aquatic ecosystems and the foundation of aquatic food webs. Phytoplankton alone produce nearly half of Earth's oxygen and drive global carbon fixation. Their biomass is not just vast, it's vital. They include algae, plankton, amoebas, and countless other microscopic life forms. Though invisible to the naked eye, their biomass is staggering. This cube represents the carbon biomass of all protists, about 4 gigatons. That's twice the biomass of all animals. Archaea are among the most ancient life forms on Earth. They thrive in boiling vents, hypersaline lakes, and deep sediments. Though invisible to the eye, their carbon biomass is immense, estimated at 8 gigatons. This cube represents the carbon biomass of all archaea. At over 1.5 kilometers per side, it's larger than any animal group and even double the biomass of protists. Fungi are the hidden giants of the biosphere. From mushrooms to mycorrhizal networks, they decompose, recycle, and connect life underground. Their total biomass is estimated at 12 gigatons of carbon, far more than all animals combined. At over 1.7 kilometers per side, it towers above the biomass of archaea, protists, and animals. Bacteria are everywhere, on your skin, in the soil, in the ocean, and miles beneath the surface. Though microscopic, their carbon biomass is estimated at a staggering 70 gigatons. This cube represents the carbon biomass of all bacteria. At over 3 kilometers per side, it's larger than any other life form we've seen so far and 6 times the biomass of fungi. We've explored animals, fungi, bacteria, and more. But now we arrive at the final cube, the one that defines the biosphere. This is the biomass of plants, an estimated 450 gigatons of carbon. This cube is nearly 6 kilometers wide and tall. It would engulf entire cities. It's more than 60 times the biomass of all animals, and larger than fungi, bacteria, and archaea combined. And now we've seen it, cube by cube. Thanks for watching, and if you enjoyed the journey, please subscribe for more.